Hello everyone. Today now I'm going to talk about this week's lecture, whatever we learned in this week. Yeah. So this week we explore a fascinating topic about, the limitation of logic, what we often think of logic as a perfect, it's a foolproof tool for reasoning. We learned that even the most powerful logical system have their own boundaries, so yeah, and then we also learn about the flying penguin dilemma and how we can, you know, handle the uncertainty when logic isn't enough. So the search space problem, let's talk about it. Yeah. So the automated provers can perform 20,000 inferences per second, while human man is only about one. Yet human often solve difficult problem much faster. Why do you think so? So yeah. It's basically because humans use intuitive meta-knowledge and heuristics learned from experience. Instead of checking every possible logical step, we use shortcuts or lemmas to jump into conclusion. But in artificial intelligence, we can actually try to mimic this by using machine learning to help computers learn which proper proof system. This would be, taking the steps to which are most likely to succeed rather than just searching blindly. And also, we also looked at the decidability, which is like what propositional logic is decidable, meaning, it means like we can always determine if a statement is true. And the first rule logic is only semi-decidable. If a statement is true, we can prove it eventually. But if it's false, then the computer might loop forever trying to find a proof. This leads to Gödel's incompleteness theorem, which is a world-changing realization. In any complex system like arithmetic, there are statements that are actually true but unprovable. Especially as the language becomes more powerful, it risks becoming incomplete or even contradictory, like the famous paradox of a barber who saves everyone who doesn't save themselves. Now let's look at more example. Yeah, just like the flying penguin. Imagine a knowledge base that says, "Tweet is a bird. Birds can fly." Naturally, the logic concludes, "Tweet can fly." But what if we learned tweet is a penguin? In standard monotonic logic, once something is proven, it stays true. Adding the fact that a penguin can fly creates contradiction. Tweety flies and Tweety doesn't fly. The system breaks. So to solve this, we use non-monotonic logic or default logic. Here we treat birds fly as a default rule. So now we know that birds fly. And that applies unless we point specific information to the contrary tree. So this also helps solve the frame problem where we would otherwise have to list every single thing an object is in. You know? So and also we learn about the modeling uncertainty. Finally, we how do we handle a world that isn't just black and white? We use uncertainty modeling, probabilities, fuzzy logic, probability density. So yeah. So to cut it short, yeah, this week we learned about the fact that AI is just about hard logic. It's about managing contradictions and uncertainties. So understanding this limitation is crucial for building real-world system that can adapt to new information. Yeah, with that, I would like to conclude this like video. Thank you so much.